All right, welcome back everyone to another explainer. Today, we're going to completely reframe how you look at backend testing. Look, for a lot of us developers, writing tests kind of feels like a chore, right? Just a box you got to check off before a pull request actually gets approved. But a backend without tests, that is incredibly risky. Sure, it might work beautifully today, but literally nobody can safely change it tomorrow. So today, we're going to transform testing from this tedious chore into your absolute best tool for total confidence. We'll be looking specifically at how you can test a NestJS backend like a true senior engineer. Let's dive in. So, there's this core philosophy we really need to adopt right off the bat. It goes like this. Testing is not only about catching bugs, testing is about making changes with confidence. We've all felt it, right? That pit in your stomach when you're deploying untested code, just crossing your fingers and praying nothing breaks. True senior engineering isn't just about cranking out features at lightning speed. It's about building this safety net that lets you and your whole team iterate rapidly without that constant fear. Okay, moving into part 1, the 3 test pillars. This is really the foundation of that confidence we're talking about. Now, a serious backend, like the one structured in the NestJS vertical slice template, absolutely should not depend on just one single type of test. Instead, it relies on 3 main levels: unit tests, integration tests, and end-to-end, or E2E tests. This is super important because these different test types catch completely different problems across your suite, usually utilizing tools like Jest. Let's break down that first pillar, unit tests. These check tiny pieces of logic in total isolation. And because they aren't reaching out to databases or network services, the main benefit you get here is pure, unadulterated speed. They run lightning fast and give you immediate feedback on your core business rules. To see how that looks at the code level, imagine a create product handler that needs to reject a duplicate product name. To keep this test blazing fast, a unit test is going to mock the external dependencies. So instead of actually asking a real live database if a product exists, the test just mocks the product repository to instantly say, yep, true, pretending the product's already there. Then it simply verifies that your handler throws the correct error. Boom. It's fast, it's isolated, and it's highly effective for checking that business logic. But here's the catch. Unit tests do not prove that your database or your application wiring actually works. And that brings us to our second pillar, integration tests. These check multiple real components actually working together. Now, yes, they are a bit slower than unit tests, but they zoom out to verify the actual plumbing of your app. Like, can your product repository genuinely save and read a product from a real Postgres database? There is a really stark contrast in how developers handle these, though. A lot of folks try to mock their databases for integration tests, which honestly just creates fake confidence. The NestJS template we're looking at advocates for a much more senior-level practice: Testcontainers. Instead of mocking PostgreSQL, Testcontainers spins up throwaway Docker containers specifically for your tests. You actually run your code against a real, isolated database instance, and then you just throw it away the second the test finishes. Now, you might be wondering, why go through the effort of spinning up real containers? Well, because of the absolute infrastructure disasters that only a real database will catch. We're talking wrong column names, broken migrations, invalid constraints. Things like missing indexes, transaction bugs, or just incorrect type ORM mapping. A mock's database test, it would completely miss all of these, basically leaving a ticking time bomb right in your production environment. No thank you. And that leads us to the final macro-level pillar, end-to-end tests. This is where we verify the finished house from the user's perspective. E2E tests check the full application flow, literally from the exact moment an HTTP request hits your server all the way to the moment the HTTP response is sent back. Usually you'll be leveraging a library like Supertest for this. Let's trace the flow of a proper E2E test because it's pretty elegant. Given valid product data, when the client sends a post request, then the API returns a 201 created status. And finally, we verify the product actually exists in the database. This flow catches problems across the entire stack: routing, controllers, validation, handlers, and the database itself. It is the ultimate proof that your feature actually works in the real world. All right, let's move into part 2, a balanced strategy. This is all about finding that perfect sweet spot. You see, a good testing strategy doesn't just test everything at the exact same level. A genuinely bad strategy is relying solely on unit tests, which virtually guarantees you're going to miss wiring and infrastructure bugs. But honestly, the exact opposite is just as bad. If you rely only on ETE tests, your test suite is going to become painfully slow and incredibly hard to debug when things inevitably go wrong. You really need balance. So, what does the optimal testing ratio look like? Well, you want a big slice of unit tests to cover all those fine-grained business rules and weird edge cases. Then you want a medium slice of integration tests to cover your database and infrastructure behavior. And finally, you only really need a very small, highly targeted slice of E2E tests for those absolutely critical user flows. But organization is honestly just as important as the tests themselves. The NestJS template enforces this awesome structure where your test folders actually mirror the feature structure for your vertical slices. So if you have a feature folder for create product, you should have matching create product test files inside your unit, integration, and E2E test directories. This gives you instant traceability. When a feature changes, your devs know exactly which tests need to be updated. No guessing required. Here's an absolutely crucial point to take away. A senior engineer does not mock everything blindly. Mocking too much creates a really dangerous illusion. Think about it. If every single dependency is mocked, your test suite is going to happily glow green and pass, even while the real integrated system is completely on fire. It's crazy. Use mocks for your pure unit tests, use real infrastructure for integration tests, and use the full HTTP flow for EDE. Simple as that. Another hallmark of senior-level testing is how you actually manage your test data. Instead of manually typing out these massive test objects in every single test file, which is exhausting, by the way, you should really be leveraging factories and libraries like Faker. This lets you generate realistic, consistent, but perfectly controlled test data with just a couple lines of code. It keeps your tests looking super clean and focused on the actual logic rather than just data entry. Okay, moving on to part 3, reliability and CI/CD. This is all about keeping the house strong over time. Listen, the absolute biggest threat to your testing culture is a flaky test. You know the ones, a test that sometimes passes, sometimes fails, and literally no code has changed. A flaky test is dangerous because the team very quickly loses trust in the entire suite. To prevent this, tests must never, ever depend on fixed global database states. Each test has to prepare its own data, be completely isolated, and clean up after itself using things like test transactions or schema resets. If you're currently dealing with flaky tests, you need to actively hunt down these exact culprits. We're talking shared mutable state, or tests that accidentally depend on the order they're executed. You might be relying on real-time delays, or using random data without setting constraints. Or maybe it's external third-party services, a dirty database state left over from a previous test, or those sneaky race conditions. Eliminate these and I promise, your suite becomes rock solid. So let's zoom out a bit and see how this all builds into your actual CI/CD pipeline. For real continuous integration, your code has to successfully pass through a series of really strict gates. First, you install dependencies and run your linters. Then, you run those blazing fast unit tests. And only if those pass do you actually invest the time to run the slower integration and EDE tests. Finally, if and only if all the tests pass, the application builds. We really need to internalize this. Testing is not decoration. It is an engineering control. It's the ultimate gatekeeper of your product's quality. A backend should never, under any circumstances, be deployed to production if the test suite fails, period. So I want to leave you with this final kind of provocative question. Think about the code base you're working on right now. If your test suite flashes green today, are you genuinely confident enough to instantly deploy it to production? If the answer is no, then it is absolutely time to implement these senior-level practices. Start building that true, unshakable confidence. Thanks so much for joining me on this explainer. Keep learning, keep testing, and I'll catch you in the next one.